In a set of real numbers, when we square a number, the result can never be negative. Even if have a negative number, when we square it is a positive number. So a complex numbers was created so that we can have a square of a number to be negative. So imaginary unit was defined as I equals square root of -1. So I square is -1. And complex number are numbers in this form: a plus bi. A and b are real numbers. For example, 5 plus 2i, 3 minus 4i, minus 16i, 10 minus 3i. These are examples of complex numbers. So this would be the real part, and 2i would be the imaginary part of the complex number. Square root of minus a when a is greater than 0 can be written as I square root of a. So because square root of minus a can be written as square root of -1 times a, which is equals to square root of -1 times square root of a, and square root of -1 is I. Therefore, square root of -a is the same thing as I square root of a. So for example, square root of -16 can be written as I square root of 16. So the -1 part, that's I. Same thing with square root of -70, I square root of 70. So square root of -25 is I square root of 25, which is 5i. Square root of -10 would be I square root of 10. Square root of -500, that's I square root of 500. And 500 can be written as 5 times 100. And square root of 100 is 10, so this is 10i square root of 5. Negative square root of -18, so that's -I square root of 18. So this -1, that's the I, the negative here, it stays there. And 18 can be written as 9 times 2. And 9 is 3 squared, so that's -3i square root of 2. Here are a few examples of products and quotient involving square root of -a. For example, square root of -7 times square root of -7. So that's I square root of 7 times I square root of 7. And we combine the I times I is I square. Square root of 7 times square root of 7 is 7. And I square is -1, so that's -7. Square root of -6 times square root of -10. So similarly, you can take the square root of -1, so that's I and I. So that's I square, and square root of 6 times square root of 10 is square root of 60. And square root of 60 can be simplified because it's 4 times 15, and 4 is 2 square. So that's -2 square root of 15, because I square is -1. Can do the same with division. Square root of -20 over square root of -2, so that's I square root of 20 over I square root of 2. So I and I can cancel out, so we get square root of 20 over 2. So that's square root of 10. Square root of -48 over square root of 24. So that's I square root of 48 over square root of 24. So the I stays there because it's just itself, and the rest is just real numbers. So square root of 48 over 24. So that's I square root of 2. So these are very similar to the ones on the previous page. Go ahead and try them and then check the answers. We can add and subtract complex numbers that are of form a plus bi and c plus di. So a plus bi plus c plus di is a plus c plus b plus di. So basically we can combine the real parts together, a and c, and the complex part together, b and d. And similarly with when we subtract. Let's look at a few examples. So 3 minus 4i plus -2 plus 6i. So we combine the 3 minus 2 and minus 4i plus 6i. So this is 1 plus 2i. 3 minus 2 is 1 and 6 minus 4 is 2. So for here, so negative 4. So let's simplify this first, because minus of the parentheses we get minus 6 plus 7i. And then we can combine the 4 and the minus 4 and the minus 6 and the 3i and 7i. So that's minus 10 plus 10i. Go ahead and try work on these and then check the answer. When multiplying complex numbers of the form a plus bi, it follows a similar rule as when we do x plus 2, x minus 2 times x plus 3, for example. We just do first term, multiply to each of the second term, and then the second term multiply to each one. So makes more sense with the example. 2 minus 3i, 3 plus 4i, so 2 times 3, and then 2 times 4i, then minus 3i, minus 3i times 3, minus 3i times 4i. Then simplified 6, this is 8i minus 9i, this is minus 12i squared. So this is 6, 8 minus 9, that's minus I, and I squared is minus 1. So it's 6 minus I plus 12. So the total is 18 minus I. 4 plus 3i squared. So that's 4 plus 3i times 4 plus 3i. So that's 4 times 4 plus 4 times 3i, then 3i times 4, then 3i times 3i. So this is 16 plus 12i plus 12i plus 9i squared. So this is 16 plus 24i, 9 times negative 1. So 16 minus 9, so that's 7 plus 24i. Here we have 6 plus 5i times 6 minus 5i. So we get 6 times 6, 6 times negative 5i, 5i times 6, and 5i times negative 5i. So we get 36, this is negative 30i, that's 30i, and this is negative 25i squared. So 36 still, and negative 30i plus 30i, so that cancels out. And so we left with negative 25 times I squared, which is negative 1. So the result is 36 plus 25, which is 61. Go ahead and try these and then check the results. So out of all these examples, this one is special because the result is a real number. There's no complex part, there's no I. This one has 8 minus I, minus 14 plus 2I, 5 minus 12I. This one is just 13. As well as this one, 61 that we did earlier. This product gives just a real number. So the reason being this one is called complex conjugate of each other. 6 plus 5i and 6 minus 5i. They are the same number, 6 and 6, 5 and 5. The only difference is this is plus and minus of the complex part. So these are called complex conjugate. So when they multiply each other, we get a real number. And the result is just 36 plus 25, which is 6 squared plus 5 squared. Same thing here with 13. So it's just, this is negative 2 and negative 2, and this is negative 3 plus 3. So this is also complex conjugate, and result is just square 4 square of negative 2, which is 4, square of negative 3, which is 9. So add them up, you get 13. So this is the general rule for complex conjugates. So for real numbers a and b, a plus bi times a minus bi, we get a squared plus b squared. So the result, there's no I in it at all. So here, let's do a few examples. So 3 plus 2i times 3 minus 2i. So we can do a shortcut. So 3 squared plus 2 squared. So this is 9 plus 4, which is also 13. And here, 3 minus 4i times 3 plus 4i. So this is 3 squared plus 4 squared, which is 9 plus 16. So that's 25. So here we're going to look at a couple different ways of dividing complex numbers. So these two are different because of the denominator. This denominator has both real parts and complex parts, 5 and 5 minus I. So this one only have the complex part, the I part. So let's first do this one. So for this type of quotient, we have to multiply by the conjugate of the denominator. So 3 plus 2i, 5 minus I. So the complex conjugate of 5 minus I is 5 plus I. So we have to multiply at the top and the bottom. The reason we do this is so that the denominator now is a multiplication, a product of two complex conjugates. So that means the result's gonna be a real number. So that's the goal of dividing complex numbers, is to get rid of complex numbers in the denominator. So here 5 minus I and 5 plus I. So this is 5 and 1. So the result is 5 squared plus 1 squared. And the top we multiply as usual. So that 3 times 5, 3 times I, 2i times 5, and 2i times I. So the top part is 15 plus 3i plus 10i plus 2i squared. So the bottom part is 25 plus 1, which is 26. So 15 plus 13i minus 2 over 26. The result is 13 plus 13i over 26. In this case, we can simplify because 13 and 26. So we can factor out 13. This is 1 plus I over 26. So 13 and 26, we get 2. Or 1 over 2 plus 1, 2i. So the result has no more I in the denominator. So that's the goal of dividing complex numbers, is to get rid of the I in the denominator. So for this one, 3 times 3 over I. This one only has the complex number part. This one is actually simpler. So we can just multiply it by I, because I squared would be minus 1, and that would get rid of the I in the denominator. So the top part is 3i, so this is I squared. So it's 3i over minus 1. So the result is minus 3i. So here, this one we multiply by the conjugate of the denominator. So 1 plus 2i, the complex conjugate of this would be 1 minus 2i. So we multiply both the top and the bottom by 1 minus 2i. So the top part we get 6 plus 6 times negative 2i plus 2i times 1 and 2i times minus 2i. And the bottom part This becomes 1 square plus 2 square. And simplify the top, we get 6 minus 12i plus 2i minus 4i squared over 5. So this 6 minus 10i plus 4 over 5. So we get 10 plus 10i over 5. And in this case, we can simplify, we can factor out 5 from the top. So we get 5 times 2 plus 2i, and the 5 and the 5 can cancel out. So the result is 2 plus 2i. So this one, similar to that one, negative 5 over I, we can just multiply by I, both at the top and the bottom. So the top part becomes negative 5i, and the bottom is I squared, which is negative 1. So the result is negative 5i over negative 1, so that's 5i. Here we look at the powers of I. So I to the power 1 is I squared is negative 1, I to the power 3, so that's I squared times I, and I squared is minus 1, so that's minus 1 times I, so the result is negative I. So I cubed is negative I to the 4th is I squared times I squared, so that's minus 1 times minus 1, so that's 1. So I to the 5th, so that's I to the 4th times I, so that's 1 times I, so that's I. So it actually comes back to I. And I to the 6th, so I to the 4th times I squared, so that's 1 times negative 1, so that's negative 1. I to the 7th is I to the 4th times I cubed, so that's 1 times negative I, so the result is negative I. And I to the 8th is I to the 4th times I to the 4th, so that's 1 times 1, so it's 1. So actually the results repeats every fourth power. So I to the 4th is 1, and I to the 8th is 1. And then it goes back to I, negative 1, negative I, 1, I, negative 1, negative I, 1. So the cycle keeps repeating every fourth power. So I to the 12 would be 1, I to the 16 would be 1, etc. So here you want to simplify I to the 15. So we can think of I15 as I to the power 12 times I cubed. And I to the power 12, that's 1. So, and I cubed is just negative I. So the result is negative I. Another example, for example, I to the power of 22, for example. So a multiple of 4 that's close to 22 would be 20. So we can break it down to I to the power 20 times I squared. So that would make 22. And I to the power 20 would be 1. And I squared would be negative 1. So the result is negative 1. For negative exponent, we can do it by the reciprocal. So this is 1 over I to the power of 3. So I to the negative 3 is 1 over I to the power of 3. And I to the power of 3 is negative I. In this case, we need to divide this because we cannot have I in the denominator. So for this case, we can multiply by I, both the top and the bottom. So the top part is I, and the bottom part is negative I squared. So this is I over, so this is I over negative of negative 1. So that's I over 1. So that's just I. So for here, I to the power 25. So 25, the closest to the multiple of 4 would be 24. So we can do I to the power 24 times I. And I to the power 24 is 1. And so the result is just 1 times I, which is I. So I to the power of negative 13. So we can do 1 over I to the power of 13. And I to the power of 13, we can break it down to 12. Because that's the multiple of 4. So I to the power 12 times I. And I to the power of 12 is 1. So we get 1 over 1 times I, which is 1 over I. And now we can multiply both the top and the bottom by I, so that the bottom becomes I squared. So this is I over I squared, and I squared is minus 1, so I over minus 1, so the result is minus I.